In this module, we will begin by building a clear understanding of heat, one of the most important concepts in air conditioning and HVAC systems. We will first explore the basic relationship between molecules, heat, and temperature, and how molecular motion determines thermal behavior. Next, we will examine the different methods of heat transfer, including conduction, convection, and radiation, and how these processes affect system performance. Finally, we will study the kinds of heat, such as sensible heat and latent heat, and understand how each type plays a critical role in the design and operation of air conditioning systems. By the end of this lesson, you will have a strong conceptual foundation for all future HVAC topics. The GTAC series is divided into two sections. The 10 modules of the GTAC 1 section provide the language and foundation you will need to understand the basics of air conditioning. The 9 modules of GTAC 2 contain more advanced material on mechanical air conditioning systems. To ensure your understanding of the material, answer the skills check questions scattered throughout each module. Check with your instructor if you need additional help. By reviewing the student skills inventory at the end of this module, mastering the material, and checking your knowledge through the skills checks, you will be using the building block learning process effectively. It is important to understand the material in each module before moving on to the next building module. This module is an introduction to air conditioning and refrigeration. Study it carefully. If you don't thoroughly understand the refrigeration process, you will have trouble with later modules. Think of it as building a house on a solid foundation. This module and the next lay the foundation for the remainder of the program. They contained the 8 foundation blocks shown in the diagram. Cooling as a means of extending the usefulness of foods or providing comfort has been known for hundreds of years. In the earliest days, such cooling was a luxury available only to the privileged and was obtained primarily by using naturally produced ice. In the winter, ice from lakes and ponds was caught and stored in insulated storerooms for summer's use. The majority of this natural ice was used for food storage in stores, restaurants, and homes. Just prior to the end of the 19th century, man-made ice appeared. The first mechanical domestic refrigerators were marketed around 1910. Since then, refrigerators and freezers have moved from a luxury to a necessity. Today, practically every home has one or more. The term air conditioning, as you will learn, encompasses several methods of conditioning air. For now, we will focus only on the cooling aspect of air conditioning. In that sense, air conditioning is a form of refrigeration. Although modern air conditioning was developed before 1940, it became increasingly popular in theaters, offices, and automobiles in the 1950s. With more and more people accustomed to air-conditioned offices and cars, it was a natural transition to want air conditioning in homes. Today, in the U.S., over 70% of homes have air conditioning, although in warmer areas this figure exceeds 90%. To understand air conditioning, we must first understand the principles of refrigeration. There are hundreds of types of mechanical refrigeration systems with many different component arrangements. If you try to learn refrigeration by learning about each one of these, you will have a very long and difficult task ahead of you. On the other hand, if you work diligently at learning the basics of refrigeration presented in the first 3 modules of this program, you will be able to understand any type of refrigeration system. That's because the principles of mechanical refrigeration and the essential components of a system are the same, no matter how big or small the system, and no matter how things are packaged within that system. We'll begin by learning about the things all refrigeration systems have in common. Then you will find it easy to determine what makes one system differ from another. As shown in the schematic diagram, a mechanical refrigeration system has 4 basic components: the evaporator, or indoor coil, the compressor, the condenser or outdoor coil, and the metering device. A fluid, a liquid or gas, called refrigerant, is circulated through each component for the purpose of removing heat. It flows between components through refrigerant piping in the direction indicated by the arrows. The order in which it flows through the four components is always the same for cooling applications. This diagram gives an idea of how a system might look in a real installation. Before we study the 8 building blocks that form the foundation of refrigeration, we'll answer 3 important questions. What is refrigeration? What does it do? What forms does it take? Simply defined, refrigeration is cooling by the removal of heat. Heat is a form of energy which man cannot destroy. Therefore, when heat is removed, it is really transferred from a place where it is not wanted to a place where it is less objectionable. Even though we tend to think of refrigeration as a way of producing coldness, we should really think of it as a process of moving heat. When heat is moved, the temperature of the substance it moved from drops, while the temperature of the substance it moves to rises. Let's look at 2 practical ways this principle applies in refrigeration. The first is a living space cooled by a central air conditioning system. In order to cool the space, heat must be moved from the air indoors to the air outdoors. This happens in several steps. First, the heat is moved from the indoor air to the refrigerant circulating through the evaporator. This causes the temperature of the air moving over the evaporator to drop. Next, the heat is absorbed by the refrigerant in the evaporator and is moved along to the condenser. Then the heat moves from the refrigerant to the outdoor air. This causes the outdoor air temperature to rise as it flows over the condenser. Now, with the heat removed from the refrigerant, it can be circulated back to the evaporator to repeat the process. A refrigerator is another example of how heat movement by refrigeration is related to space temperature. To keep food cold and avoid spoilage, heat must be moved from the food to the air in the room. As in the air conditioning example, this happens in several steps. First, the heat moves from the food into the surrounding cooler air. This increases the temperature of the air and decreases the temperature of the food. Next, the heat that is now in the air from the food moves into the refrigerant that's circulating through the evaporator coil. This causes the temperature of the air coming off that coil to drop. That heat is then moved along by refrigerant flow to the condenser coil underneath, where it is moved from the refrigerant to the room air circulating over that coil. This causes the room air temperature to rise. In both examples, refrigeration moved heat in several steps from the place where it wasn't wanted to a place where it was less objectionable. The result was a lowering of temperature in the area from which heat was removed and a rise of temperature in the area to which the heat was transported. Both the above examples used mechanical refrigeration systems to move heat. Ice or chemicals also could have been used, but throughout this series we will limit our discussion to mechanical refrigeration systems. Mechanical refrigeration applications can be divided into 4 basic categories based on temperature and use. Although this program emphasizes comfort air conditioning, we will briefly look at all 4 applications. Even though we are focusing on cooling, the term air conditioning means much more than that. Complete air conditioning is provided by a system which will heat, humidify, cool, dehumidify, ventilate, filter, and circulate air. Obviously, most systems we call air conditioning do a partial job and are technically not total air conditioning systems. As we study refrigeration systems, we will focus our attention mostly on the cooling function. In spaces occupied by people, Comfort air conditioning uses refrigeration to cool and dehumidify air to achieve comfortable conditions. The temperature and humidity conditions accepted as comfortable by the industry are 68 to 78 degrees Fahrenheit, with 75 degrees Fahrenheit as a typical goal, and 20 to 60% relative humidity, with 50% as a goal. Refrigeration refers to a mechanical refrigeration process to cool and freeze foods. It also involves the production of ice for commercial uses, such as ice rinks and ice storage. Grocery stores make extensive use of mechanical refrigeration. There we find coolers for dairy products, produce, and meats at about 35 to 45 degrees Fahrenheit, as well as freezers at -20 to +30 degrees Fahrenheit. Household refrigerators and freezers are smaller versions of the systems found in grocery stores. Many of the basic concepts taught in this program will apply to these types of equipment.
We are committed to sharing knowledge and helping everyone improve their professional skills. If you enjoy this type of training, please like this video and subscribe to the channel. The next episode will be even more exciting, so don't miss it. You are also welcome to leave your comments or email us with the topics you are interested in. We will select the most requested topics and discuss them in future episodes.